Okay, we're in section 10.2. We just completed the lecture. We're going to do the examples over here. As I do the examples, I want to point out what happens to a lot of students on exams. They'll often say, hey, teacher, what's IVT? By doing that, when you get to an exam, what you're doing is communicating to me that you've done nothing as far as preparing for exams. Like when someone says prove using IVT, you should know when you're at calc. I mean, maybe a year from now, you're not going to remember this, but IVT stands for intermediate value theorem. All right. So often on exams, sometimes students don't understand that and they don't answer the question, or I might answer it in a kind of a sarcastic way that you should know that it's the IVT. The IVT is the intermediate value theorem, and you know what that theorem states. What do I mean by that? Well, we covered it. I mean, this was covered in Math 119, and you should know what you have to do to use the IVT. However, I want to point out a lot of students on exams, they think back and they say, oh, gee, I can solve that equation. That is not answering their question, by the way, and I will go through that. All right. But anyway, we'll go through this over here. As I do this, we'll talk about it in detail. All right. The next one, prove using IVT. Again, IVT stands for intermediate value theorem. Again, we will do that in class. There's two problems to do, and they're familiar to me. One is a root problem that you've done in Math 100. The other one is going to be a trigonometric problem that you've done in Math 120. All right. Now, granted, they're not asking me to solve it, but I want to talk about that too. All right. So let me go through this one step at a time. I'm going to go to the whiteboard. And I want to talk through the questions over here. Now, granted, I'm kind of curious about the first problem. It looks like a Math 100 question to me. So what I'm going to do is I'm just going to pull it to the side. And I want to point out this is a Math 100 question if I'm not reading. And that happens to me a lot of times. A lot of times when I'm looking at people's exams, particularly at the Math 100 level, I don't even read the question, by the way. But if this was a Math 100 question, let me go through this with you. If this was Math 100, the question would be solve. Let me see if I can do that. So in Math 100, what they told you to do is isolate the root. Well, there's two roots, so I'm going to isolate one of them. Then they told you to square both sides. Most good nightmarish, right? Whoops. That would be x plus 2 equals, that's a root of x, 9 minus, what would you get there? You get minus 3, which is minus 6 root x plus x. I'm in a loop. All right, so what do I do over there? I guess I have to take x from both sides, right? That's pretty simple. I guess I would take 9 from both sides. That's pretty simple. What do you get? You get minus 7 equals minus 6 root x. And then I guess what you do is you would divide both sides by minus 6, and you would get 7/6. And, you know, I make mistakes sometimes. I kid you not. Sometimes I think I know what I'm doing, but I don't know what I'm doing. What does this give me? 49 over 36x. Now, what did your teachers tell you to do in Math 119? They told you to, I'm sorry, 100. They told you to check it. So let's write this down. What do I check it? Always in the original. So what do you get? The root of 49, 36 plus, wow, this is going to be a tough one, right? So it's 49 over 36 plus 2 equals 3. I got some work to do here. So that would be 7, 6 plus, I got to do that fraction, don't I? And what would that give us? Well, common that would be 36, right? So you get 49. And 2 times 36 is 72, isn't it? Well, what do you get there? Let's see, 121, right? Let me see, make sure that's true. 121, 40 and 70. That's 110, 11. Yeah, 121. So I got to make my eraser out, my baby arithmetic, right? And when you get over 7, 6 plus 11, 6 equals 3. I have no idea if this is true. What do you get? 18, 6 equals 3. Oh, that's true. That's true. So here's the problem. So let's say you get a calculus got back from a student, and let's say it's question number 1 in the exam, and then it's a 10-point question, and I put down minus 10. Now, what am I saying? You did not do what you were asked to do. So although I know the answer, they didn't ask for the answer. Let's go back to their question. Make sure you understand that this doesn't get any credit, what you just did. You got to read. So it says prove using the IVT. So I'd have to know what the IVT is. Well, what I'm going to do is, what I like to do with the IVT is I really see the IVT as a root existence problem. So really what I'm looking to do is write a function down. And a way to do that, I'm going to take my equation. This is an equation. I don't need to solve it. And I'm going to solve that for 0. Why is that? I'm really looking for a root. So root x plus root x plus 2 minus 3 equals 0. So what I'm going to do now is I'm going to define a function now. My function is f of x equals root x plus 2 minus 3. That's the function. Now, by the way, I need to get a closed interval where this thing is continuous. So I'm looking at it and I'm going to say the domain of it is 0 forward. So I'm going to say I'll start at 0. But then I want to think to myself is what's an easy number for me to go to that I could probably do? And I'm going to, it's up to you what you want to go, but you could say, oh, I'll do 1. I could do 2. I could do 3. I could do 4. I could do 5. I want to play it safe. I'm going to go to 10. So I'm going to claim this is a function, f of x is continuous. So I'm going to say f of x is continuous on the interval 0 to 10. All right. I'm going to choose my w to be 0. So what I'm going to do is, I don't know, maybe it's not going to work. Maybe I'm going to do a different interval. I'm going to do f of 0. What's f of 0? It's minus, well, that's a tough one, isn't it? That's 0 root 2 minus 3. Wow, that's a tough number. Not really. What do I know? Root 2 minus 3 is definitely less than 0. Right now I'm going to do f of 10. And this could get tough too. What do you get? Root 10 plus root 12 minus 3. Well, I hope you realize root 10 is 2 point something and root 12, I'm sorry, root 10 is 3 point something. Root 12 is also, this is definitely bigger than 0. All right, that needs to be stated, by the way. Now, someone says I chose different numbers. Well, use the numbers that you choose. I chose that interval. Now, what am I saying over there? Well, I'm saying now there is a C on the open interval between 0 and 10 such that the f of C would equal 0. And what are we using? The IVT. All right. Now someone says, oh, in your notes, you didn't use 10, you used 7. Use what you like. All right. Now someone says, why would they choose 7? I guess because 7 plus 2 is 9, and square root of 9 is really easy to do. But let's go through it. I'm going to say it's continuous there. Let's see if I got something else down here. And then if it's continuous to infinity, certainly I could use those endpoints over there. So the closed interval I'm choosing is 0 to 7. The open interval would be 0 to 7. And certainly the same thing. I chose 10 though. All right. All right. Let me do number 2. Number 2 looks like a tough question. And I want to point out to you, when I say tough question, again, if you want to about this in a wrong way, it's a tough question. Let me just make sure I got number 1. Let me see if I'm reading the footnotes okay. Yeah, I got the 4936 over there. And by the way, I want to point out that I got a solution to this problem as well. I'm not asking you to do that though. I'm not asking you to do that. So what do we have to do? IVT. So what I have to do is I got to remind myself about the arctangent function, right? So I'm going to remind myself about arctangent. I'm doing number 2 now. So what's the domain of arctangent? Well, it's minus infinity to infinity, and that's for the arctangent function. That's its domain. Now I want to do the domain for the arc cosine function. Well, that's between -1 and 1. All right. Now, where'd you learn that? In math 120. Now, when I say learned it, I don't mean memorize, I mean learned. that you learn things, all right, that you learn things in Math 119. Now you might say, no, everything's a memorization skill. That's not an education. You need to learn things. How do you learn things? By studying those things. All right, so what I'm going to do is I'm going to write my function down now. So I'm going to take this, and I really do like roots. And what are roots? Well, I solved that for 0. Let me write this over here. Arc tangent of x minus the arc cosine of x equals 0. I'm going to put my function down now. I'm using the IVT, by the way. Arc tan of x minus the arc cosine of x. I'm going to choose my w to be 0. I like that w to be 0. You'll see me do that almost all the time. And what I'm going to do, I'm going to say that f of x is continuous on the closed interval between -1 and 1. Now, by the way, it might be wishful thinking, but like a lot of wishful thinking, I'm going to see if it works out. What am I going to do? I'm going to do f of -1. And what would you get? Let's write this down. Arc tangent -1 minus arc cosine of -1. And again, I'm not memorizing, I'm reasoning. This is going to be minus pi over 4 minus, what's the arc cosine of -1? That would be pi. I'm going to say this is clearly a negative number. I don't get to do much beyond that. Now, by the way, if it's below 0, I'm hoping that f of 1 is above the 0. I don't know. Let's take a look. What do you get? Arc tangent of 1 minus arc cosine of 1. Again, I'm not memorizing, I'm reasoning. What's the arctangent of 1? Pi over 4 minus the arc cosine of 1 is 0. Clearly, it's a positive number. What do I now know? I now know there's a c on the open interval between -1 and 1 such that f of c would equal 0. What are we using? IVT. All right. So let's take a look, see what they've done, work what we've done in class. They did something spiffy over here. They got a solution to the equation. All right. So what I'm going to say is it's not an easy question, but I just want to, kind of briefly go through it. Right. If you were to solve this thing over here, I'm going to say visually, the arctangent looks like this. And let's take a look. You know what? I gotta just do something real quick. Yeah, I did that. Say arctan of 1 is 0. Yeah. So I'm gonna say it looks sort of like this over here. That's the arc cosine. I know there's a point of intersection. All right, I'm gonna briefly go to software. And software is gonna be something you wanna be aware of. So let me just stop the share. I'm gonna do another share. And I'm going to share my desktop with you. And what I'm going to do is I'm going to try Wolfram Alpha today. And let me see if I can do that by opening up a web browser for you. Wolfram Alpha. And I'm just playing around with software. So I'm going to say solve. Oh, by the way, I don't know if it's going to work. Square root, SQRT. Plus square root. Let's see, x plus 2, right? That equals 3. I made a mistake in typing. I got to type that again. Sorry about that. I'll correct that over there. It's a plus sign. Wow, 4936. Same thing we did. We're not using the IVT though. We're just using Wolfram Alpha to get a solution. Now let's see if we can do Wolfram Alpha in this one over here. This is very easy software to use. However, I want to point out they're going to be eventually, if you keep using this, going to keep asking you for money to buy the product. No, that doesn't annoy me, but it annoys a lot of people. Wow. Is that the answer I gave you? Yep, same answer. All right, same answer. All right. I also want to talk about another piece of software. And that software I want to talk about is graphing software. Now, when I do graphing software, what I'm going to claim over here is I'm not telling you what to use. I'm just telling you there's options out there. There's tools out there. And you should be, impressed by tool use. Let me graph this out. Arctan of X. That's graphed out. And I'm going to graph the other function out, which is the arc cosine. And I'll put that down for you. Arc cosine. And I'm seeing that. The rough picture I gave you before wasn't too bad. And what are you getting over here? You're getting a point of intersection. Let me just select both of those curves. And I'm going to do the point of intersection now. Let me see if I can do that. Find intersection. And I'm going to say, looking at the picture, they want me to give an approximate to it. I'm going to say it looks about 0.8 to me. And what do I get? It gives me like a crosshair, and it's saying the value of that for the X would be 0.7862, 0.6662 for the Y. All right. So let me do the other one. I'm going to point out this is a visualization process that you've done in math 119. Let me do another problem. Let me do this one over here. And I'm going to write down that's y equals square root SQRT X. I'm visualizing now, plus the square root SQRT of X plus 2. I'm going to graph that out. And the other function I want to graph out is 3. There's 2 functions there, left and right. All right, so this is, I don't even see what you're doing over there. I'm going to pull a curve around, and I want to do the point of intersection. So let's do that. Find the intersection. And what does it give me? Oh, geez, I guess I took the last guess I had. But it gives me that value. And what value did we say it was? If you recall, I said the X was something, right? What did I say the X was? I said the X was 49 over 36. Well, if you compute 49 over 36, you're going to get that number over there. All right. Let me go for that. Go over here. 49 divided by 36. 1.36. Yeah, they're rounding it. Actually, their approximation is not that good. 1.3605, 1.36. Yeah, their approximation is a little bit off. But anyway, that's fine. Their approximate answer is good enough in the tolerance of the machine. Thank you.